Good day, everyone. We're here again to continue the lesson 3.1 Understand and Represent Exponents. I know that we only did the first two parts of this lesson, so we'll continue part 3. Again, just a reminder that our essential question is how can you write and evaluate numbers with exponents? Also, that you could always tell yourself that I can write and evaluate numbers and exponent. And we're not gonna go over the overview because we're just gonna jump into to exercise number 3. But for that, I have a challenge question for you. Okay, here's the challenge question I have for you. Tara wants a new carpet for her dining room. Her dining room is a square that has a length of 5 meters. What will be the area of her carpet that covers her entire dining room? Then I want you to express your answer in exponential form, and then I also want you to evaluate this answer. I'll give you a minute. All right, I hope you got your answer. So we know the area is length times width, no matter what, if it is a square or it is a rectangular shape, right? So it just happened that this problem has 5 meters is the length, and since it's a square, so the length and the width is the same. And I asked you to write them in exponential form. So the area will be 5 times 5, correct? So that will be 5 times 5. It means that is 5 squared. Also, it means that that is 25. And since it is in meters, so that's going to be meter squared. How is it meter squared? Because we also do meter times meter, so they're going to be meter squared, the two of them. So if you got your answer in exponential form and in evaluate form, then you guys got your answer correct. All right? Okay, let's move on. All right, so here's our example number 3. Julia calculated a foil as 1.9 times 10 to the power of 5 units thick. The Thumb calculated the foil as 183,000 units thick. Sorry for that. Which calculation represents the greater thickness of the foil? Again, we'll read it. Julia calculated the foil as 1.9 times 10 to the power of 5 units thick. Thumb calculated the foil as 183,000 units thick. Which calculation represents the greater thickness of the foil? I'll give you a minute. So we do not need to evaluate 182,000 because it's already in a regular or a standard form. Let's see what happened to 1.9 to the power of 10, not 10 to the power of 5. We know that 10 to the power of 5 is 100,000. So therefore, we're going to multiply 1.9 times 100,000. That gives us 190,000, right? So therefore, to compare those two numbers, even though it is in this form, we know that 1.9 times 10 to the power of 5, because 10 to the power of 5 is 100,000, becomes 190,000. So therefore, 190,000 is greater than 183,000. There you go. I want you to try this on your own. Raphael calculated the foil as 1.8 times 10 to the power of 4 units thick. Evaluate Raphael's expression. I'll give you a minute, pause this video, and we're gonna answer it together. All right? Okay, so let's do this. So that's 1.8, right? So this 1.8, and when you evaluate 10 to the power of 4, that's time, sorry. So that's gonna be 10 to the power of 4, so we're gonna have 4 zeros, correct? 1, 2, 3, 4. That's a shortcut when you get that power. So now with your calculator or with your own what do you call that, hand calculation, this is gonna be how much? That's gonna be 18,000 or 8,000. There you go. So that's 10 to the power of 4 is 10,000 times 1.8 is 18,000. All right, let's try another one. Alright, here's another foil problem. Terence calculated the foil as 1.1 times 10 to the power of 5 units thick. Aaron calculated the foil as 183,000 units thick. Which calculation represents the greater thickness of the foil or for the foil? I'll give you a minute. Alright, so if you said that Terence calculated less than 180,000, you're correct, because Terrence will only get 110,000, because 1.1 times 10 to the power of 5, right? So that becomes 110,000 is less than 183,000. Let's try another one, and this one is on your own. Still foil problem, all right? So it's easy, correct? Chicken. So 1 times, how much is 10 to the power 4 has 4 zeros. So that means that is 10,000. So 1 times 10,000 is 10,000. It's so obvious that 180,000 is so greater than 1 times 10 to the power of 4. Alright, I hope you understand this lesson, guys. Alright, just a little go back or key concept reminder that the exponent, the blue one is the base and the 4 is the exponent. But also call that little number 4 there as power. And we know that the power is being used to identify how many times the base is going to be multiplied. So 5 to the power 4, we multiply 4 times. So that's going to be 625. Most of you miscalculated that. That becomes 5 times 4 is 20, which is not correct. Because exponent tells us to multiply the base how many times, not to multiply it with the base. So for example, 5 to the power 4 is 5 times 5 times 5 times 5 is 625, not 5 times 4. I hope you clarify that to yourself and remember that all the time. Alright, I hope you understand our lesson for today. It's a continuation of a lesson from previously. So good luck, and we'll have more practice in our workbook in classroom. Alright, good luck guys, and stay safe all the time. Until next time, bye for now.